Okay, we're going to be looking at the differential of exponential functions. I'm going to show you how to do this two ways. I'm going to show you by using the chain rule and also by using the formula here. I'll just highlight it for you on the right hand side. Now, some of you may choose to use the formula below it because it seems to match it perfectly. However, I don't. I don't use it, and if you want to use it, well, that's fine. That really is up to you. So, in actual fact, during the course of this activity, you will see me not using this formula at all. But I leave that choice to you. I'll explain why towards the end of the video. First of all, I'm going to use the same technique that we used in the previous lesson for the inverse trigonometric functions. I'm going to quote what the formula is. The formula is that I'm going to be using that y is equal to e to the power of x, and when we differentiate it, we get dy dx is equal to e to the power of x. So it's a fabulous function because when you differentiate it, a basic e to the x function does not change. Now, in the context of this problem, it's the same as before. We're looking at what does the x in the formula actually equal within the question. And the x in the formula is equal to 3x. And as we saw in the previous lessons, we're now going to differentiate this formula x with respect to x. And of course, when we differentiate 3x, we get 3. And this becomes the multiplying factor. So we're now going to apply the formula. So dy dx is equal to e to the power of x. Well, what does this power of x actually equal in the context of this problem? It equals 3x. So the e function does not change. But it has a multiplying factor, and that multiplying factor is 3. So that's method number one. And the reason why I teach that method is because it's a follow-on method from the inverse trig functions that we did in the previous lessons that you should now be getting correct. So let's look at method number 2. And method number 2 is using the chain rule. So y is equal to e to the 3x. And the primary function is the e function. And the secondary function is the 3x. And what does the chain rule say to us? The chain rule says differentiate function A and then multiply by the differential of function B, and then multiplied by the differential of function c. There's an ABC problem. So let's see how this works here. And also, remember, nothing else changes. So here, what do I know from the formula? I'll highlight the formula again in a few minutes. When I differentiate an e function, well, what I know when I differentiate an e function, it does not change. You know, an e function does not change. It remains the same. So when I differentiate this function here, the e function, it doesn't change. So it's e to the 3x. And now I multiply by the differential of the b function, and the differential of the b function is 3. So both methods are incorporating the chain rule, but this one is slightly faster, but it involves a bit more of a memory game. Okay, we move on. Example number 2. Method number 1. We're going to use y is equal. Again, I'm going to ignore this formula here completely. I'm just not going to use it. You'll see why as we progress through. And I'm going to look at purely using this formula. And what it actually says is the first function y is equal to e to the x. And when we differentiate it, dy dx is also equal to e to the x. The x in the formula, I'm now going to compare it to the power in the question, and the power in the question is minus 7x. So the x is equal to minus 7x. So when I differentiate this, because this is the chain rule, this is actually the chain rule written out in a much longer format. Differential of this is minus 7, and this becomes the multiplying factor. So we're going to be using the formula dy dx is equal to e to the x. So let's see it in the context of what we're about to do. So therefore we're going to have our blue dy dx is going to be equal to e to its x, which is minus 7x, because the x here is equal to minus 7x. And then we're going to multiply by the multiplying factor, which is minus 7, which now, when we tidy it up, is going to be minus 7e or minus 7x. And that is the same technique that we used again for the work on inverse sine, inverse cos, and inverse tan functions. And it is a clever way of setting out the chain rule, relying on formulae. But now I'm going to do exactly the same problem again, and you have to make your choices. Y is equal to e to the minus 7x, and this is my priority A function, the e function, and this is my priority B function. So now I'm going to, and you should listen to my language. My language is I'm going to differentiate the left-hand side. When I differentiate y with respect to x, I get dy dx. It's meant to be in blue. Dy dx. Now, in differentiating priority A and differentiating e function, it remains the same. So it's e, nothing else changes. And then I multiply by the differential of the secondary function, and that's going to be minus 7. It's exactly the same as above, except skipping all the working out lines. So then it ends up being minus 7 on e to the minus 7x. This question is only worth maybe 5 marks. If you forget to multiply by the minus 7, you are going to lose 3 of those 5 marks. The method here, if you learn it effectively, works in lots of areas of mathematics. It is longer, but it does guarantee you very, very good marks. It's essential that you focus on it. Okay, let's go on to the example number 3. Now, example number 3 is, I hope you spot this, it's the product rule. And that this is key. You have to spot that this is the product rule. And because it's the product rule, you've now got a situation where you're starting to label up. This is the first function, and this is the second function. In your head, you will say this: first times differential of the second plus the second times the differential of the first. You shouldn't be writing it, but you should be saying it. But what you should be writing is dy dx is equal to the first times the differential of the second plus the second times the differential of the first. Then you should be going off to one side, the way we usually do it, and you should be writing down, well, what is my first function? Well, my first function is x squared. And what's the differential of my first function? Well, the differential of your first function is 2x. You just got 3 out of 10 marks just for doing that. What's your second function? Well, your second function is e to the x. What's the differential of e to the x? And the differential of e to the x, well, it's here. The differential of e to the x is e to the x. So you've now got that. So what you have now is 5 marks out of a possible 10. Now, what you've got to do is substitute it in. So dy dx is equal to, well, what is the first? Well, you go and read it. Just literally read it, nothing in your head. And that's x squared. And then multiplied by. And what's the differential of the second? Well, the differential of the second is e to the x plus, that's in the formula, plus the second function. There's your second function, which is e to the x, multiplied by the differential of the first function, which is 2x. And that should be 10 out of 10. Unless, of course, they ask you to show that question where they need you to factorize it, or where they expect you to factorize it, in which case it's 7 out of 10. So what's the common factor? I'd like to think I could pause here and you tell me. You should be pretending this is you in the classroom. You should be thinking. And the common factor clearly is okay, so what is the common factor? Well, the common factor is clearly e to the x for both, and also x. So we're going to take out x as a common factor. And we're also taking out e to the x as a common factor. And then we're opening up our bracket. So we're left with x plus 2. And being able to factorize this later on in the course is absolutely essential. So you need to do it for your homework. And that's the end of that 10-mark question. Going on to example number 4. And we've got the same problem again. You had to, first of all, recognize it was the product rule. And then because you're recognizing it's the product rule, and this would be regarded as being quite a hard question, you would then write down your formula, dy dx is equal to the first times the differential of the second plus the second times the differential of the first. You then will be writing down what the first is. Well, the first is equal to x to the power of 5. So the differential of the first is equal to 5x to the power of 4. So technically at this stage you've already passed the question. You've got a H8 because you've identified the fact it's a product rule. You've actually started to use the formula and you've got one of the differentials correct. So now for number 2, we've got the function number 2 is equal to e to the 3x. Now I'm going to do it the way I showed you in the previous examples in a few minutes. But for those of you who want to see a slightly faster method again, involves a bit of memory, it's up to you whether you want to employ this. But listen to my language. When you're differentiating an e function, it does not change. So the differential of an e function is e to the 3x, and then you multiply by the differential of the power, and that's going to be multiplying it by 3. In actual fact, what we're doing is very sneakily is we're using this formula, the one I said that I don't use, ironically, but in this particular circumstance it does speed it up. But that isn't the way I did it. I didn't use that formula per se. I used a technique. When you differentiate an e function, it does not change, and then you multiply by the differential of the power. So, what's the other way of doing it? Well, what we saw earlier on. You write down y is equal to e to the x, dy dx is equal to e to the x. What is your value of x in terms of the formula? The value of x is 3x. You differentiate it to work out the multiplying factor, and the multiplying factor is 3. Okay, and therefore when you differentiate y is equal to e to the 3x, you end up with dy dx. Well, you differentiate the e function and it remains the same, e to the 3x, and then you multiply by the multiplying factor, which is 3. It's a lot longer. This method here is a lot longer than either using this method or learning what I said earlier on. Now, here we go. Let's finish it off now. So we're going to have dy dx is equal to the first, which is, reading it up here, the first is x to the power 5 multiplied by the differential of the second, which is going to be 3e to the 3x, plus the second, which is e to the 3x, multiplied by the differential of the first, which is 5x4. Now, again, if that's all they want you to do is differentiate it, you've got full marks. But sadly, for higher level, they want you to differentiate it, and then you will need to factorize it in order to move the problem on. So what's common? Well, e to the 3x is common to both. What else is common? An x to the 4. An x to the power of 4. So now what we have here is dy dx is equal to, well, we've already said that x to the power of 4 is a common factor. Also, e to the 3x is a common factor. So there we are, factorized it. The e to the 3x has come out, so that's all gone. So we're just left with a 3 there. X to the 4 has come out, so we're just left with an x to the power of 1. Here, the e to the x has come out, all of the x to the 4 has come out, so what we're left with is 5. And that's the end of that problem. Moving on. We've now got y is equal to e to the sine x. And hopefully now you'll see why I used what I was using earlier on. So let's see method number 1. Y is equal to e to the x, and the derivative, the differential, the dy dx, all the different terminologies for it, the slope function, is also equal to e to the x. What is the value of x? The formula value of x, when I compare it to the question, is equal to sine x. I'm now going to differentiate and the differential of sine is equal to cos x, and this is going to become a multiplying factor. So now I'm back over here and I'm going to differentiate this. Dy dx is equal to, what does my formula say? It says an e function. What does my formula say? That when I differentiate an e function, it remains an e. So therefore, when I differentiate an e function, it remains an e. What's the value of x? It's sine x. What's the multiplying factor? Multiplying factor is cos x. So now we've got dy dx is equal to cos x on e to the sine x. And that's method number 1. Now, when I show you all these methods, my view is I don't mind which method you use in the end, but make sure you get it right. Now, method number 1, the one I've just shown you, is if you learn it, will work in lots of different areas, and you will always get the question right if you learn it properly. Method number 2 is the chain rule question. And this is going to be priority, the e function is going to be priority A, and the sine x is going to be priority B. And when we use the chain rule, differentiate the y, we get dy dx. When we differentiate an e function, which is the priority A function, it does not change. That's what the formula says. When we differentiate an e function, it doesn't change. So it stays e to the sine x. And then what we do now is we multiply by the differential of the b function, which is cos x. And that's the end of that example. You might just gently rewrite it with the cos x at the front. Okay, and then you've got method number 3, which is a wordy method, and now you have to listen to my language. When you well, maybe I'll just write it down and you could learn it in words. When you differentiate an e function, you write down the e function and then multiply by the differential of the power. Obviously you don't write that down every time you do it, just learn it. So for example, if I've got y is equal to e to the sine x, that's what the sentence above is going through my head. So therefore I do dy dx, because differential of y with respect to x is dy dx. If I differentiate an e function, you write down the e function again because it does not change, and then you multiply by the differential of the power. And differential of sine x is cos x. And that is the quickest method if you take the time to learn what's above. So we'll see it here. I'll use the last example. Dy dx. When you differentiate an e function, it does not change, so it's 2x squared minus 6x plus 2, and then you multiply by the differential of the power, which is going to be 4x minus 6. And that's the end of it. That's how simple it is. Of course, the other way of doing it is using method number 1 that I've been using all the way through, which is just a tad longer. You've got y is equal to e to the 2x. I didn't really leave myself much room there, did I? Let's do that again. Just a little bit more space. Y is equal to e to the 2x squared minus 6x plus 2. And then y is equal to e to the x. We know from the formula book that dy dx is also equal to e to the x. The x in this context is 2x squared minus 6x plus 2. So when we differentiate it to get the multiplying factor is 4x minus 6. So when we come back here and actually apply it, dy dx, when we differentiate an e function, it does not change. And the multiplying factor is 4x minus 6. We would have a tendency to put the multiplying factor at the front. So you've got 4x minus 6 on e to the 2x squared minus 6x plus 2. Okay. Log functions. Log functions. All right. So go to the formula book, and what we have is we've got if y is equal to log x, this is from the formula and tables book, then that implies, according to the formula and tables book, that dy dx is equal to 1 over x. So how do we do this? Well, what's the value of x? The value of x from our formula relates to 5x minus 1. We're now going to differentiate this to get the multiplying factor. So differentiate this x to get the multiplying factor. And the multiplying factor is 5. So now we're going to apply the formula. So y is equal to ln 5x minus 1. So dy dx is equal to, well, what does the formula tell us? Well, the formula says it's 1 over x. Now be careful, because that isn't x. That x is this x, and this x is 5x minus 1. That x is what's in here. So that's 5x minus 1. And then don't forget, we have a multiplying factor. And the multiplying factor is 5. So we multiply the top of this by 5. And we end up with dy dx is equal to 5 over 5x minus 1. There's quicker ways of doing it, and we'll explore that again later. For now, I want you to focus in on this method that we've used for inverse sine functions, exponential functions, and now log functions. Again, we quote the formula from the formula book, formula and tables book. Y is equal to ln x implies that dy dx is equal to 1 over x. So when we differentiate the y with respect to x, I don't know why I did that, sorry about that. We now, what is our value of x? Our value of x is equal to tan x. We're now going to differentiate the x with respect to x, and we now need to go to our formula and tables book in order to look up what the differential of tan x is. I'd appreciate it if you now start reaching for your formulas and tables books and go to page 25. And if you go down page 25, you'll see that tan x, when it's differentiated, gives sec squared x. And this is going to be our multiplying factor. So now we're going to do the original problem as set. We've got y is equal to this. And now we want to work out what dy dx is. And dy dx is, well, according to the formula, it's going to be 1 over, and the x value is tan x. And we're going to multiply that by sec squared x. Now this one gets slightly more difficult, not because of differentiation, but because of the tidying up. So we've got dy over dx is 1 over. Now tan, you now have to go to page 13 of the formula book, and tan is equal to sine x divided by cos x. And that's going to be multiplied by sec squared. And if you go to the formula book, you will see that, again on page 13, that sec a is equal to 1 over cos a. So sec squared x will be 1 over cos squared x. So therefore here we're now going to have 1 over cos squared x, which I'm going to write as cos x on cos x. And what we have now is that we can now cancel that cos x with this cos x. We then end up with dy dx is equal to 1 over sine x cos x. And again, quite depressing. You could end up having to even rewrite that, because if you go to the formula book, you'll see that 2, and this is on page 14 of the formula book, 2 sine a cos a is equal to sine 2a. So sine a cos a is sine 2a divided by 2. So 1 over sine a cos a is equal to 2 over sine 2a. So using that formula, dy dx is now equal to 2 over sine 2x. And then just a final insult to injury, of course, 1 over sine is cot. So we've now got dy dx, could be written as 2 cosec, not cot, cosec 2x. Because 1 over sine is cosec, because 1 over sine is cosec. Now, it's rare that you have to do from there downwards, but it is possible on the harder questions, which are specifically designed for H1 students. So if you aspire to achieving H1 stroke H2, then this last few lines are quite important. If you're just aiming for H3, then finishing here is absolutely fine. Example 8. I'm going to do y equals ln x over e to the 2x. And what you should spot straight away is it is actually the quotient rule. So therefore you should be quoting the quotient rule formula. Dy dx is equal to the bottom times the differential of the top minus the top times the differential of the bottom all over the bottom to be squared. The bottom is equal to e to the 2x. So the differential of the bottom, well, when you differentiate an e function, it does not change, so it's still e to the 2x, and then you multiply by the differential of the power. The differential of the power is 2. The top is equal to ln x, and then straight from the formula book, the differential of the top is 1 over x. So now we're in a position to actually do it. So dy dx is equal to the bottom, which is e to the 2x, times the differential of the top, which is 1 over x, minus the top, which is ln x, times the differential of the bottom, which is 2e to the 2x, all over the bottom to be squared, which is e to the 2x to the power of 2. That technically is a correct answer. You probably get 7 marks out of 10 for that, or 10 out of 10 depending on the problem. I'm not going to take it any further today. I'm just going to leave it at that. I'm not going to do any more log questions today. I'm going to set specific questions from 13.8. Right, the questions I'm going to set from 13.8 are as follows. I want you to do (13.8)(1) odd parts only. Question 2, odds. Question 3, odds. Question 4, odds. And that is all I want you to do. You've got 2 days to work on that. You need to be working in your study groups. You need to be helping each other and whittling down the misunderstandings to an absolute bare minimum. I need you working together on this so that we actually minimize the number of problems that I have to go over in class, so that we're focusing on problems that are relevant to as many people as possible. This is why I've given you 2 days to do it in. Right. All the best.